Today we'll be talking about inequalities. Next we'll be talking about the Cauchy-Schwarz inequality. So this is the statement of the inequality. We give a very short proof of this, which involves elementary algebra. Consider the following polynomial, where each of the terms, the polynomial generated by summing all the squares of aix plus bi, where ai and bi are the sets of numbers in the Cauchy-Schwarz inequality. So we can actually expand this and we'll get the following expression. We note that the polynomial as a sum of squares is non-negative, hence it has at most one root, and therefore its discriminant is less than or equal to 0. This discriminant is it is the expression given below, and from this inequality the Cauchy-Schwarz inequality follows. As a side result, equality holds in Cauchy-Schwarz if and only if all of the ai and the bi are linearly related to each other, because that is the only possible case where all the sums of the squares is 0. So now we have an example from SMO Junior. Given that a greater than b greater than 0, show that the following expression is at least 10. So we will bound the second fraction, then we use AMGM to get the answer. So 3 over ab minus b squared, we factorize the denominator to obtain 3 over b times a minus b. So we know that a minus b is positive because a is greater than b. As such, we can apply the AMGM inequality to get that this expression is greater than or equal to 12 over b plus a minus b whole squared equals to 12 over a squared. Now we can convert back to the original expression, and we note that we get square root of 2a cubed plus 12 over a squared. So we wish to show that this is at least 10. To do this, we need to split the powers. We need to eliminate the powers of a such that when we get it into the geometric mean form, the a's cancel out. As such, we divide the a cubed into 2 portions, and we divide the a squared into 3 different portions, such that a cubed times a cubed divided by a squared cubed gives you 1. So in this case, we note that if you use the AMGM inequality, the result follows easily. So note that in this case, we can actually find the equality case. Equality occurs in both AMGMs that we have used. So that means that b equals a minus b, square root over 2a cubed is 4 over a squared. So that means a equals 2b, and a to the power of 5 is 4 square root 2, which is square root of 32, or square root of 2 to the power of 5. So that means that a and b must be root 2 and root 2 divided by 2 respectively. Next, we give a simple illustration for Cauchy-Schwarz inequality. Let x, y, z be positive real numbers such that the following expression holds. We wish to find the minimum value of x plus y plus z. We simply apply the Cauchy-Schwarz inequality directly. Multiplying that expression by x plus y plus z, we know that it is greater than or equal to the square root of 24 plus the square root of 54 plus the square root of 294, and you square everything. Because the expression in the first bracket is actually 1, we know that this is greater than or equal to 2 square root 6 plus 3 square root 6 plus 7 square root 6. Everything squared, which gives you the square of 12 root 6, which is simply 864.